Now let's dive into getting random samples from a distribution. And this is one of my favorite functions because this, as a data scientist, I care a lot about how we can get data from this distribution.
You love data.
Yes, so any distribution, we can use the RVS function to take random samples based on that distribution. So the first distribution I have here is randomly choosing between 3 options where we have a 66% probability of failing because 2 options are a failure, and a 33% probability of succeeding because one of the 3 options is success. So because we have a 1/3 probability of being successful, this looks like a Bernoulli distribution that has a probability of just 1/3. So I'm going to go ahead and from my scipy.stats library, I'm going to import the Bernoulli distribution. So Bernoulli. And then I'm going to go ahead and create a distribution of a Bernoulli. So I'm going to say D is equal to Bernoulli of P is equal to 1 divided by 3, or 1 out of 3 successes. So our success rate is 1/3. And now I want to sample from this Bernoulli distribution. I want to get random values that are either 0 or 1 based on that probability distribution. So to do that, I can simply say D when I have my distribution .rvs. So if I do D.rvs, what do you get, Carly?
So if I do D.rvs, I end up getting a 1.
A 1. So we sampled from this distribution getting a 1. That was the unlikely choice. There's only a 33% chance probability of that. So if you rerun it, what do you get?
If I do it again, I actually get 0.
0, and a few more times.
Let's do it a few more times. So 0, 0, 1.
Awesome, and this is what we expect. We see more 0s than 1s because it's more likely there's a 66-67% chance we get a 0, and only a 33% chance we get a 1. But this is kind of tedious, so we can often want to sample multiple values. So you can actually give a parameter or an argument to the RVS function. So if we do D.rvs, we can take 10 sample values, for example. So D.rvs of 10 gives us 10 sample values as a list.
Yes.
So if you do this, what do you get?
So it says array and then 0, 1, 0, 0, 0, 0, 0, 0, 1, 0.
Oh, interesting. So we got a little bit unlucky here because we only got 2 1s.
Only 2 1s.
But we saw that it is more likely to get a 0 because there's a 66, almost 70% chance of getting a 0 and a 33% chance of getting a 1. So our expected value was 3 1s, and we got pretty close to that expected value.
Yeah.
So the nice thing about RVS is it works both on discrete distributions as well as continuous distributions. So if we look at standard normal distribution, we can do the exact same thing. So I'm going to go ahead and import that. So from scipy.stats, import norm. And then I'm going to go ahead and create my distribution D is equal to the normal distribution, a standard normal curve. And then I want to go ahead and let's sample just once just to make sure it works. So D.rvs.
And I got -0.31.
-0.31. So right around the center, just slightly negative. And now I want to really see a bunch of different samples. And what I expect to see is a normal distribution is centered at 0. Half the values should be positive, half the values should be negative. So I expect to see half positive values, half negative values. And I expect to see very few values below -3 and very few values above +3. Because there's very little area under the curve, either to the left of -3 or the right of +3. So if I do D.rvs of, how many do you want to do?
Let's do 20.
20? We should see 20 different values.
Yes.
And are about half them negative?
Yep, half negative, half positive.
And are they all sort of in the range of 0 or 1-ish, plus or minus?
Yes. The biggest one is 1.51, it looks like, and the smallest one is -1.7-ish.
So that's exactly what we expect to see. All the values are clustered, and there's probably going to be more values with zeros, either plus or minus 0 than 1s.
Yep, exactly.
So we see that it's actually sampling from this distribution, and this is really valuable because as data scientists, we can use this in simulation to project different values from the normal distribution by using the RVS function and getting a new random value every single time.